Good evening, heroes and heroines, and welcome to Practising Programming in C, where we're going to be, first of all, fixing up this little problem we introduced yesterday. It seems we've broken asset hash updating again, so we need to figure out how we've done that. And then we're also going to then go on to sort out how we're going to sync up the project hierarchies in the database and the configuration file. And also, you might remember yesterday, we were looking into hash editors, hex editors, and we didn't find one that we liked. We're kind of sick of the one that we're using because it doesn't show colours, nor does it show it doesn't show an indicator where you're up to when you're like navigating through the hex stuff, the binary side. It doesn't show you. It has an area that shows like an ASCII representation of the things. It doesn't like show where you're up to in the binary side on the other ASCII side. After the stream, I sort of realised that we have actually got the program that we still got the program that I used to use. We used to use one called Hex. And it actually still exists. It still works, and this is it. You can see this guy. It shows the colours which we want. So all of the nothings are red. I think these are probably. I think these are all like potentially ASCII values. Right, so you can sort of marry up these guys here. Right, so these are going to be printing characters, I guess. I mean, there's also this. So maybe alphabetical characters are this colour, alphanumeric characters are this colour, symbols, ASCII symbols are this colour, and then you've got things that are, I guess, just integers that are just lower than the smallest kind of ASCII value, I guess, or just in white. So you can see that there's that colouring, and you can also see on the other side. So this is the binary representation. Here's the ASCII representation of it. You can see that there's this little orange indicator here. If I just move rightwards, you can see that moves in that side and it moves in this side. So you can basically look over there. I mean, say like I want to look at what this thing is over here. I'm interested to see what that is. I can go over there, and then I can switch my gaze back over to this side to see that we're on a 2. So it's a bit more usable it's a bit more usable. But I think the only problem that I had previously, it was with like when you go up and down the page. I think when you go, there was some weirdness. I can't remember exactly what it was. Yeah, Control F doesn't work for a start. What have we got going on here? So yeah, you can't go. So there's Control D. You can go down, I assume, half a page. Well, actually, no, that is a full page, actually. Now, what's going on here? I think this is screwed, isn't it? Now, if I go down to the very end, in fact, that's another thing. I don't think you could. Well, okay, so that's the very end. Then if you navigate upwards, I don't think it's doing this exactly right. You can see it's only moving the top line, so I'm not sure if it's probably not intentional because it's only now redrawing these bottom ones that go down. So there's some dodginess going on. But I think this is at least a little bit more usable. And as long as we're aware of that, those bits of dodginess, we can sort of work around them, I suppose. So yeah, that's our hex editor for the time being. So let's go over to what I'm looking at. We encountered this this error here. This was with updating the topics.css. So this path is correct in HTML files. Now this line should get printed out without a new line. So that's why that's why we're seeing the next thing here. Now, home mat temp Cinera test hero code handmade hero isn't a valid, like that is an unexpected thing essentially. What I would be expecting to see here is a base file name, or an entry, basically it would be the entry output, wouldn't it? I'd be expecting to see the entry output here. So it's going to correspond with one of these dudes, right? I should really be expecting to see code 81 actually there, is what I would expect to see. Because test hero code, but we've got handmade hero. Now it would have got handmade hero from the project header, which is gonna be prior to the entry, basically. Let's go to line 2475 first of all. It seems like Snapchat when close file is receiving the wrong HTML file, essentially. Right. We're saying we're getting no such file directory, then it's continuing on to continue on into this function. So it's going to be read search page into buffer. Well, it's either that or it's this one here. Oh, that's a point actually. It could be. Yeah, it could be this actually, couldn't it? Now that I think about it. Yeah, it could totally be that, couldn't it? Because the search page is going to be, the search page has an index of -1. So it's possible that that is screwing it up, isn't it? It's possible that when it tries to snipe that checksum and close file, actually, no, I'm going to bring that back. I think the search page should automatically know that it is supposed to be located at test hero code index.html. Basically, it should be talking about this file here, the one at the bottom. So since we're seeing more information after this, I think we do know that we're down to this area here. Right. Now, The running landmark index should get set by this. So yeah, I think this should have. Might be worthwhile making this a wider value, by the way. In fact, yeah, let's totally do that. We've got our first landmark set up here. So the pointer is the asset. The first landmark is going to be the asset there. I think let's first of all try and reproduce the error. So I need to actually, first of all, because we haven't done this bit yet, we need to remove the database and also I mean we don't need to remove this, but we might as well, I guess, just so we're back to the start. So if you run Cinera, now we did delete one, but let's just see if you can reproduce it. Splash. Let's see if we can reproduce it just like this. Yeah, perfect. So there's nothing to do with deletion. It's reinserting. So let's delete our dudes. Let's run it once. I mean, strictly speaking, I should probably also actually let's see if we actually do exhibit the error here. Yeah, okay, cool. So that means that we can actually run it once and then run it under the debugger. And still trigger the error. Line 2468, I feel like we've jumped straight into line 2468 on a previous attempt to do some stuff. Right, so we didn't hit that. TT1PD. TT1PD. So the landmark in file could also be a longer value, couldn't it? So apparently, but yeah, there's one landmark in file, and this is going to be for the search page, isn't it? What are we taking? It was the call on line 2737. So it's this one, yeah, for the search page. Read search page into buffer, HTML first landmark. So I guess the first thing is, do we get through this? Generation 0, index 0. That's going to be a problem. Because we don't have any landmarks for that project. So yeah, that's going to screw us over. isn't it? Let's continue though, see what happens. I think we're back in the file, are we? Maybe, I don't know. Should we have a look at this path? I think this should be the correct path, isn't it? Yeah, code inits HTML. But I don't think that this landmark could be a mistake, but I don't think that's done the right thing. Anyway, we now come back through what we see for landmark. Again, we've got a generation 0 and index 0, which is surely incorrect, I think. I say this is surely incorrect, by the way, because we set the we set this project generation equal 1 here, right? So what we're basically saying is that we want to be operating on the hero project, this out of hero project, and so this top level thing is the generation 0. We want to go into hero and say, and also the way we've the way we're defining the generations or the project indices is by generation and then by index, including all of the people in that generation. So the code is going to be the first person in the, it's going to be the 0th entry in the first generation. Ray's going to be the second entry. Sorry, Ray's going to be the first entry in the first generation. And then if we're going to come down to this project risky down here, this is also in the same generation. This is in generation 1 as well. But it's going to be 0, 1, and then this is going to be index 2 in the first generation. Right, that's the way we've kind of specified it. Now, having set this generation 1, we do locate the project. Yeah, I suppose we just don't know, do we? We don't know what this is supposed to be. Is that right? Because this is just locally initialized. Right, and we only initialize it for the purposes of locating the project. Result of project entry points is equal to that. I suppose what we actually need to do also, yeah, that's what we haven't done, isn't it? We've done it a bit wrong. Although, have we actually? Now that I think about it. Locate project. Yeah, locate project operates on an index. So I think, yeah, I do think we've done this a little bit wrong. What we want to actually do is say the result project index project generation. Right. And it's essentially this actually. But you don't have that at all. You actually do it like that. And then I think everything should propagate down a bit more correctly. Still a little bit cheesy, but let's see if that helps us out at all. acid moine idle. So that's more like it. You now got generation 1, index 0, which is what I want to be seen. And then here we go. We're going to locate that entry, and we're going to actually be locating the correct thing now, I reckon. Yeah, so we've now got the generation looking correct. Not exactly sure where we've gone to here. But yeah, we've got that. And we can look at the entry, actually. I suppose I could have looked at the entry previously, actually. But we can now see that the HTML base value is correct. I mean, for that matter, I could actually just redo that and just see what actually happened. But yeah, we've now successfully read that page into the file, into the buffer, and successfully done it. So yeah, I think that was our problem. Updated checksum of that. Now, if I don't do that, build that. I think we're going to have to go through to this area here. Right, so now we've got the landmark, generation 0, index 1, 0, which is incorrect. We now set the entry. Now what is this saying? This is probably going to be bogus. Yeah, HTML base family in this code. So that is garbage. It's complete and utter nonsense. Isn't it? I suppose actually, now that I think about it, locate entry should be erroring, shouldn't it? Right. Yeah, I mean, we can remember that we need to do this again. If we do locate entry, so DB header project locate, so that's going to be locate the project. If project, I think we want to also say if project and the entry index is less than the project entry count. Then we can go in and we can actually return that entry. Otherwise we can't. Right. I think that sounds a bit more reasonable. And then down at the other end, only if there's an entry do you go into this situation here. Does that sound reasonable? the error is basically like that the entry index for the landmark is basically invalid, really. Invalid landmark. Invalid landmark. How is it invalid? It's invalid because the entry index is greater. Well, we don't actually know, do we? We don't know whether it's because we couldn't find the project or whether we couldn't find the entry, to be fair. So do we have a print landmark? Actually, do we need to even do, like, who's calling this? Oh, it's not even called by anyone. Okay, fine. I imagine surely the, what's its face we have to call it, won't it? The examine database function we'll have to call it. And also this is going to be a long signed. Yeah, this is going to be the L project. Hang on a minute, let's just see. Yeah, project generation index, and they're not longs, so we'll have to figure that out. Project generation. I think we wanted to do for, didn't we? So should we just do that? Shouldn't be a U, should it? No, it shouldn't. Cool. And then this dude, is that also just a U? And let's get this one, well, it's the final one, so it doesn't matter. We don't care about aligning that. Yeah, I think that's what we'd like. And then just We will also need to move this upwards because it's at 256 where we need to report this, isn't it? Oh, it's here. Init block, is that used? Yeah, that's used by locate asset. So where's our error? So, if I just quit, I think we should still have our invalid landmarks. In fact, actually, yeah, I could just let it run, honestly. TT1PD is still playing. Guess we've just got a break, haven't we? We hit an invalid landmark, it's just got to be... We need to know what assets it's for as well, don't we, actually? Can we do that? A print asset? I think we want to wrap up that file name actually into a string. I suppose we could, because the file name could be a variable length, let's print the hash. Let's print the type first, actually. Do we have the type names? I think we do somewhere, don't we? Yeah, I think type names. So it's going to be the asset type. It's going to be CSS. Well, hang on a minute. How do we usually... Let's just run it again. Let's just see what we actually currently print out. Appended. Okay, so JavaScript assets, Cinera search. So we're doing that. All right, let's just do that, frankly. So it's a thingamajig asset, file name, and then the hash. So it's the type. And then finally the a hash, and also, well, actually, that was it. Let's just say that it's that. I'm not sure if we would need to report this failure. Possibly we won't actually. Yeah, I suppose actually update a checksum of. So I guess actually, now that I think about it, we've tried our best, haven't we? Let's just see what we're producing first of all. FLH, capital L, F, capital L, H. Suppose we just don't bother to try and align that stuff, and also I think we're within our rights to do that because we know that our callee is going to not not have done that. Yeah, I mean, I think it didn't die, did it, really? I mean, although it does say updated checksum. Right, so I think we do need to say, we do need to return an RC and say, what is this? One of them. Oops. Now that I think about it, actually, all of this is going to have to happen, isn't it? The only difference is that we print out different stuff, I guess. And also, it's just that, like, updating that, if you say invalid landmarks, is like, you just sort of know that it's that. And this, I mean, it shouldn't really get hit, really. Gloss. Updating that. Invalid landmark. CSS has it. Yeah, I guess aborting update. Because that's basically what's going on, isn't it? By the way, you've noticed that I've just forgotten to delete the this guy. I think it is actually working. Strangely enough. Could be mistaken, but because that's one lot of hero code. Oh no, it's not. There's RISC-V reader up here, and then we've got another RISC-V reader down there. So, oh, there's hero code. Yeah, so we're just spewing out too much stuff, basically. But that's the thing we're going to address in the rest of the stream. Ceramic. So invalid landmark, aborting update, CSS assets, that. I think that should do for now. So when we init the neighborhood, what we want to be doing is just actually that. So again, we're going to have a bunch of extra garbage at the bottom of this. So here's all hero code. We've got another hero code here, and then we've got another hero popping up down here. Hero code. So we're just piling on projects to our thing with abandon. But now if I do 9 fly, I think this should now correctly update. So shim ripple. Inserted that, updated that, perfect. Alright, so that was the only problem. The only problem we had was that we were failing to use the correct. We were failing to set the neighborhood's project index essentially. Now this kind of actually begs the question: if we're locating a project, and we're returning a pointer to the DB header project, wouldn't it be nice if we returned an actual project index? Maybe it wouldn't actually, now that I think about it. Maybe we should keep them separate, because there could be instances of yeah, there aren't really, are there? I was going to say maybe there are instances of locate projects that don't care about having the entire project index. Yeah, I guess the corollary is locate entry just returns the pointer to the entry, which isn't bundled up with anything. So maybe we're entitled to just say that the locate project thing just returns the pointer to a project in the same way that a locate entry returns the pointer to a DB entry, and that's just how it goes. Then let's move on to the next thing, the main thing, which is basically syncing up the trees. And then let's come back to this whole situation of figuring out project indices and making sure that we're operating on the correct project. Once we actually have more things to be dealing with, I guess, because we're still currently just hard coding this particular project to be this one here, and then just operating on this as the current project. So yeah, let's wait until we're dealing with the full lot. Oops. Sync DB init project. So here we go. Let's also just note that we've fixed this. Refers to the correct project, the labels landmarks indexed into the wrong project. Well, that'll suffice. Okay. Init printing DB. And this init initializes it recursively. Right, we've got an hour until we've done 2 hours. Just give us a couple of minutes and then I'll dive into this. Try and figure this out once and for all. Be right back. Alright, so I think I'd like to start off by planning out what we're actually doing here. As a kind of overview, what we're doing is we're trying to synchronize up the hierarchy of projects in both the database and in the configuration file. Right, so we've got this kind of a situation. Let's see if we can just give us a bit more space. 8162. What's that times 2? probably that, isn't it? Nope. $8192. Okay, so we're going up to 16384. Definitely do need to get Milton involved, by the way. In fact, how much space we're using? Well, we're fine. So do we have this group here? We've got this hero group. We've got that risky. We've got bitwise. And then we've got that, this. So can we... Is there a nice way for us to group all of these fuckers together? Basically, I'd like to just take all of this and copy and paste it. So this is going to be our config. This is going to be the config. Cool, I can do that. Right, cool. Don't want to be part of that. I want to be part of this. And then what is all this? These are just all the kind of textual parts of it. Oh, the... Yeah, I'm going to lose the thing, aren't I? Now I think about it. You know, the actual tree. That's unfortunate. Yeah, this is definitely not something we want to really be particularly interested in doing. Can we just... Yeah, we can't select multiple dudes, can we? Yeah. This is garbage. It'd be so much nicer if I could just like say select all these, you know, if it was just like in Vim, just like select all these dudes and just like just stick them down there. You know, copy and paste them basically. So there should probably be more 2 ones. Yeah, there is. hardware and software should be under here array, shouldn't they really? Interestingly enough. It's kind of insane that we're effectively building up a tree of an actual tree. Sort of. Okay, so now if I just select that is selected the whole thing. So I believe I should be able to move this entire dude around, shouldn't I? Yeah, but it just forgets about that. So what I propose we do is we copy that background layer. And then what we do is we crop it to these actual locations. And then we stick that also into the cut thingy. So this is basically the right. So then I should be able to say, oops, not that. I should be able to say select all of this, delete all of that, and now what have we lost? Ah, is that obscuring some stuff? Is that what's going on? Hang on a minute. Yeah, it is. So we need to give this an alpha channel. Now, having given it an alpha channel, can't we just say that the black, we remove the black? Alright, I think we're in business. If we now select everything and delete, we should now have everything in a situation where we can actually move this thing around. Yeah, perfect. So let's leave this down in the center, right? Actually, let's put it up here and say that we've got like the database to deal with. We're going to have a couple of copies of this. Right, so this is going to be the copy. Right. So it's basically like, this is what it is in the config. In the database there's nothing at the moment. So what do we have to do? We have to like insert the whole lot. This is what we have in the config still. And we do have this representation in the database. So let's do another copy of it. And this guy is the DB. Right, so we need to work out how to ensure that these guys are the same. Right. And then I think what we want to do is also give us a way, and we also, yeah, another thing we need to factor in is the asset indices, which I guess are encoded in the 0, 1, 2, and all that stuff. I think what I would like to say though is let's just say, let's give us another copy of the config. Right, but this one is going to be a bit different. This is going to also include another thing. So we're satisfied with this. I think this is the guy that we're talking about. Satisfied with that. Yeah, I'm not going to move these around because I don't know how they're going to end up combining or any of that crap. Let's say they want to add to this guy some more stuff in bitwise. And I guess also we should probably copy this down to here so we know how to change from that, or rather how do we change from this to this. Worth bearing in mind that this is the thing that is driving the entire thing, right? This is the thing that you do in the config. This is the thing that the database has at the point at which you are processing this, right? So we're basically talking about turning this thing into a thing that represents this, basically. So that's within this guy. So yeah, like I say, we need to handle deletion. I think we should handle deletion. I also think that we should handle. We need to handle reordering. Let's do this, and let's also swap risky and bitwise over. How is the ordering of these things going to be used? I think the ordering of them is going to be used in the search pages, basically. So when we have a collated search page, which is going to include multiple projects. I think we want that. I think we want the ordering of those things to be controlled by the config. So that's where that's going to come into it. So here's one for you. Let's say that we add these guys here, and let's swap risk and book. Let's swap risk and book, and also, should we just remove software and hardware? Should we do that? Just so we've got a deletion case in there as well. Yeah, let's see if we can do this. So, where's our bitwise? Hero group is all of this. I guess we could just add to this a bitwise group. You put bitwise into there. Parsing and code gen. I mean, strictly speaking, maybe the bitwise, maybe this dude should not be in the bitwise group, but should be in the outer one, to make it a bit more. I mean, it does not matter. And then we were saying to swap risk and bulk, weren't we? Let's try our best to do that. Yeah, I mean they're not groups, are they? Actually, now I think about it, this is probably fair actually, because if you want to be doing that, you also want to take the 0.2, by the way, wherever the fuck that is. Right. Yeah, strangely enough, it seems like you want the tree lines to be different. Maybe there's no getting away from the fact that the tree lines are just going to change. I don't think there's a nice way that you can really talk about that. Yeah, and it's also the numbering. I mean, I guess the numbering, strictly speaking, is going to be the same over here, although it's going to change. I think we did say though, didn't we, that we want to delete this and delete hardware. So we need to erase this little bit of information. Oh, we wanted to swap book and risk, didn't we? Let's try and do that. Right, so we're going to take this and move it over this way. And we're going to take, yeah, we've lost the indices, unfortunately. Is that, it's actually, what's that? So, tree lines, let's remove these lines here. What? Yeah, I'm not sure what's going on down there at all. Okay. Yeah, those two are over there. So now actually we need to move 2 and 1 into coadd and reader. And 2, 2 and 2, 3 don't need to exist anymore. And then we need some lines for these guys. So oh, not big enough. Yeah, that's the point. So let's just make it that size. Okay. Right. So what have we got? We've got 0, 0, 1, and 0, 2. And then we've got 1. Sorry, yeah, 1, 0, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then in this generation we've got 0 and 1. Right. Right. So right. So the database at the start contains nothing. How do you determine that it contains nothing? You just sort of say that the project the project count is 0, basically. But I don't think that's sufficient. Because of these more complex cases. So let's skip this and let's look at this thing. Right, we want to be saying, I think also I should sort of do the following. Okay, this is the config, and this is the DB. Right. Where did they go, by the way? Copy. They shouldn't be within one of these. And in fact, that should... Actually, that's fine to be there. This should be at the top level. That should. This. Guess DB group would be the thing, but fuck it. Where's config? Oh, hang on a second. Yeah, whatever. So I sort of think like what you want to do is to first of all go through the entire generation, seeing if the top level dudes, seeing if this, and this matches with this, and this. Hold on a second. Select that again. Right, so this is easy, right? You just say for, so you're looking in the projects block, you're saying for each entry, for each for the project count in the DB, I suppose also we could probably do with adding a new dude, couldn't we, actually? Should we add ABBG? Let's add ABBG and Drake to these guys, just so we've got a little bit more stuff to go on. So let's add ABBG after hero. Unfortunately, we're going to lose our lines, aren't we? But yeah, we are. I guess that's just how it goes sometimes. So what are we looking at there? The wrong one. What is this? Is this anything what we want? Nope. What's this? Don't think that's anything what we want either. Oh, it is. So what? Where's one? Oh, it's that down there. Right. So we want to be saying this risky group. We want to be moving up risky and bitwise to make space. Oh yeah, now that I've resized this tree lines later, it's not big enough anymore. Oops. I wonder. Aha. That's handy. And then can we anchor it? Perfect. Bollocks. Select this. Beautiful. Now we do need to redo the numbering. I think because we are inserting these, we do need to actually totally renumber them. So let's get rid of 1, 5, 6, 7. 0, 1. Get rid of that. I mean, let's just get rid of the lot. Start fresh. 2, 0. Where's that? One 8. Where the hell are you? And 0, 2. Okay. Then we want to do a new dude. It's got to be. No, I think it's got to be 64. I think. So this is going to be OBBG. Probably should be lower down, but who cares? And Drake. Right, so these guys are going to have just themselves. Should have been the bitwise group. Yeah, and then this is the database over there. So then we've got 2, 0 and 2, 1. And if I'm not mistaken, that is all our people. No, we don't need to be too funny about that. So yeah, now let's go back to our, well, tree lines, crop list, the content, and then just select the background layer so we've got nothing screwing us over. Right, you can't really see it, but whatever's. Now, we've got this and this. So basically, in order to determine that we've got these structures the same, I'm sort of wondering this. Do you go into the top level guys? Right, do you go through all the generations in turn, basically? And sort of say, for this generation, are these guys all the same? Right, so is index 0, 1. Does this match with this? Does this match with that? And does that match with this? If so, then great, right? We then go into the hero, and do we then just say, does this match with this match with that, this match with that, this match with that, and this match with that? And then go into the risky and say, does this match with this match with that, this match with that? Right, so in other words, you go through this top level, and then you go through this level, and then go through these people, and then go through these, right? And then, having done that, do you then go through these people, looking at their children, saying, does this match with this? Does this match with that? And then go on to the next one that has all those generations and say, does this match with that? Does that match with this? Is that what you do? Or do you try and match an entire tree at once? Right. So rather than going kind of breadth first, essentially, do you try and go depth first and say, does this match with this? Then does this match with that? This match with that? This match with that? This match with this? Then this match with this match with that, this match with that, right, to determine that that entire thing is correct. Then having done that, do you then go on to look at risky? Say, does this match with that, that, this, and then having done that, do that and that. It doesn't seem to make any difference, does it, when you are looking at things that are the same? I don't think. Other than the fact, I think, that it is less work to do the depth first one. You know, it's less work to compare an entire tree, because you don't need to keep going over the same thing multiple times, right? If you're gonna compare by generation, then you kind of need to go through each tree multiple times to determine who actually has any children, right? Because in order to say yeah, in order to, you know what I was saying, do you go, does this match with this, that, does that match with that? Right, in order to say, well, let's go for these guys. Once it's down to the second generation, it's down to generation 2, in order to say, in order to look at the generations, you need to actually basically go into everyone again, right? Having, you've just looked at the first generation 1 rather. You've gone over generation 1 to compare this against this, right the way over to this against this, right? Having done that, you then go back to square one, and you're saying, for this guy, go into its children, and it's the children of that child, right? It's like, does this guy have any children? Match those children against this children, right? That against that, and then, well, you got chat also with no children, and it's only that at that point can you say, you go to Ray, and Ray actually does have some children, so you can compare that against that and this against that. Do you need to do that? You need to do it that way, do it that exhaustively. And then having compared against those, you then go on to MISC, and you say compare their children, right? And then having done that, you then want to be trying to find these guys. Now, I suppose what I was going to say was, I suppose doing it that way, you automatically know how many people there are in this generation, but by the same token, you can just store that information, right? You could just say, as you go through the table, you could just as you go through the tree, I think you could just store the highest, the entry count of the generation 0. Right, you know that there are at least 0 generations, and there's at least 1 generation, and that there's 1 entry in that generation. So in generation 0, you already know that there's that. So you store that there's 1. Then as you go through this, you go into its children and you just increment the entry count of generation 1. Right. Increment it. Well, yeah. Increment it. You see that this guy has children, so that you go in and you say that when you see a child here, you just know that that is 2, 0. And then this guy is 2, 1. So you increment the number of entries in generation 2. Right. And then you go out, and then you do this, increment the max guys in generation 1. Right. So then as you come through, you always know where you should be up to, I think. So I'm kind of inclined here to say that what you do is you do it depth first. Like you compare this entire tree. You compare this entire tree first with this entire tree, keeping a running tally of the number of members of that generation, of each generation. I suppose what you do is you just have to push on for each generation. Each time you encounter a new generation, I guess you just have to push on an integer to a little growable thing, because you can't know how many generations there are, and you don't want to have to pre-allocate like well, actually, maybe there won't be too much harm in it, actually. If you just say that you've got an array, well, it doesn't matter. It really doesn't matter. We can figure that out when we get there. No, I think the principle is that you just keep a tally of where you're up to. So now let's see what happens when we change stuff around. Bearing in mind also, I'm not thinking of storing the entry index. Well, not the entry index, but I'm not thinking of storing the project index in the database, right? I'm thinking that is going to be essentially implicitly encoded in the location of the thing in the database. By the way, I'm just thinking here of who you actually iterate over. Right. I'm just thinking whether you iterate over the config. See, like you're doing a for project count in the config. I think you probably do, don't you? Because it's all got to come from here. So you need to make sure that you've got through this entire thing. I do appreciate that you need to make sure that you also got through the entire DB. But I think maybe you just need to say that getting through the entire DB is, well, I mean, I guess you just need to sort of you need to go through all of these, and then maybe you need to go through some residual stuff. You need to, like, having gone through this, you need to say, if we haven't got through the entire databases thing, then you need to delete those guys, I guess. Do you know what I mean? Anyway. Oh, it's, I think the music's finished. Yeah. What's going on? Off to work for Jesse. Okay. I think you can make straight lines with the pencil tool, including the start point. Totally shifting and clicking the endpoints. Dude. Where are we? The background. Oh, baby. That's beautiful. So what was that again? That was hold shift. Ah, you don't even need to click the start point. Yeah, that's pretty sweet. You just need to be hovering. Yeah, you just need to be hovering, press shift, and then do that. And also you get constrained angles with control. Oh, that's great. So I know you're not here anymore, but I think I can plus that. That's awesome. Half an hour ago. Yeah, okay. Let's continue and let's just try and go through this little dude here. Let's go through these and then let's get some food. And then we'll probably come back and try and actually implement this stuff with our newfound understanding. Now we're talking in terms of, we're going to assume that going depth first is the way to do it. So let's see what happens if we go depth first. And we're driven by this guy, right? We're saying we're driven by the config, we're looping over the config, and then after having gone through all this, we're going to try and go over any residual stuff in the database to see if there's anything that we need to get rid of. Which there won't be for our case, but we will need to kind of be aware of that. So, does hero match with hero? Yes, it does. Let's descend into hero. Does its first, do these match? Hero and C. Hero, intro to C. Do these match? Yep. Do these match? Do these match? Yes, they do. Ah. Now, here's an interesting thing. This doesn't have any children, but we won't know to descend. So I guess what you need to do is you need to say, you also need to compare, as well as comparing the IDs of these guys, you also need to compare the child counts of them. Right. So does that match with that? It does match with that. So its index is the same. And then having determined that it matches, you then say, do the does the child count match? In this case, it doesn't match. Now, I guess it's a similar principle, isn't it? It's like it's the residual stuff, isn't it? Right, there's going to be residual software and hardware in this guy that aren't existent in this. So it's like for each thing you want to then say, if they don't match, you want to then either add, well, you first of all add the dudes that you need to add. So in the case of bitwise, we're going to have that situation. Right, we're going to have to add these. And then, having added them, you then remove any residual guys, which is this, right? Now, having removed these, we know that the assets of landmark, the asset landmarks that are talking about index 2.0 and 2.1 are now wrong. So we need to then, I think immediately we then just go into those assets, and I think we just have to delete those assets. Delete those landmarks. And then, having deleted them, we also need to decrement the project index of these guys that are in generation 2. Right? I think that's what you do. So immediately upon encountering this, you need to update the indices, because you'll have all the information that you need at that point, right? Again, because you're keeping a track of you're accumulating the generation and the index as you go in. When you get to this point, you know that you're looking at generation. Well, when you get to this point, you know that you're looking at generation 2. You're going to add anybody to generation 2. Well, you go to descend into their children, right? So for every person, you want to descend into their children. You want to check that they match. And then, having seen if they match or not, you descend into their children. This guy doesn't have any, and then you, having descended into their children, you remove any residual stuff from the database. Right. You know, so if you add somebody, you then go and apply that change to the assets, which, again, this is just the DB thing. The assets is a different area altogether. Should probably actually increase the width of this and represent the assets somehow. But I guess we're sort of these numbers here, these asset indices, are just talking about those landmarks. Yeah, I think that is what you do. You offset the assets immediately. still looping over an index number. I think you are going to have change the pointer. You know, like you write this, you fix up the assets. Now, when you fix up the assets, you're going to write out to that file. So the pointers that you're looking at in the database are going to be, they're going to have to be offset, and I think they should probably automatically get offset. Is that true? Actually, maybe they're not. You're going to get the project. Yeah, I guess he's saying the current project. I guess you could sort of use. Yeah, that might need some working out actually, how you actually deal with that. Let's continue though. Having gone through this dude, you then go on to the next project. You see that it's OBBG and you say, does this match with this? No, it doesn't. So I reckon you just straight up insert this into the database at that point, right? Insert that into the database at this point, and then I think actually having inserted this guy in this generation, I think you then just go in to the look into the assets and say that everyone with generation 0, 1, sorry, everyone with project index 0, 1 gets their project index incremented to 2. Right? You can't see that, but it was 0, 1 and it has become 0, 2. And then you need to go through to everyone with, basically everybody in generation 0, at least 0, 1, at least index 1, you need to then go through all of the landmarks saying 1 and above have to get incremented, basically. I think that's what you'd say. Right, and then having done that, you go into all its children, you add its children, and I guess actually, in this case, because this one wasn't yeah, here's interesting. I think we're going to encounter something interesting when we go into risky actually, which is basically swapping over things. It's like, do you want to try and figure out if something has just been swapped? Let's see if that happens when we come to risky. But basically, you do risky, you do OBG, add its children, descend its children, and then I guess clean up any residual stuff. Although, yeah, I mean, I guess you just do systematically just do that, even though you know that you've only added it. You just simply added the dude. Although, I guess actually what you do is you just initialize it recursively, right? and then Bob's your uncle. You just, oh, mind you, actually, when you do that recursively, you need to know if you've added anyone in order to offset the generation numbers of these dudes. Fucking hell. Yeah, you probably do need to do that. Well, let's go on to risky and just see. Now, you've done this and this, right? And now, having inserted OBBG in here, this will actually already be located in the database in such a way that this could compare against that, right? Because we have literally inserted in the file a new dude, a new project. At least that's what I'm proposing. Right, so then you go, does this match with that? Yep. Descend, risky, does that match with that? Yes. Book, does this match with this? No. Now, what do you do at this point? Do you seek on to the next person and say, does that match with this? And then decide to sort of place it over here? Or do you insert one anew? I mean, clearly, like, if you're just thinking of it as a human being, what you want to do is, we can easily see that these guys are the same thing. The only difference is that the book and the risk have just been switched places. Right, we can easily see that. It's like, do you want your algorithm to actually try and determine that? What would be the pros and cons of doing that? So you look at that. So you're comparing book against risk. You say they don't match, right? If you go on and you want to go through all of the guys, all of the databases projects, which you should know, shouldn't you? Because you're working through, yeah, in order to compare against that and that, you need to know how many entries there are in this, because otherwise you just fly off the end of the project, wouldn't you? So, having found that this doesn't match with this, you could conceivably say, check the next people, right? So, having checked the next people, you see the book now does match with this person over here, right? At that point, what do? Do you just immediately say, right, take this and just stick it before risk? If you do that, then right, you take this, stick it before that, increment your maximum count of the generation index is currently now up to whatever book is going to be at this location, right? And then you descend into book and you say this and this. They're up to these values. Sorry, you descend into it and you compare that against that, right, which is newly there, and that against that. And in comparing those guys, you also increment the current count of the generation 2. So you know that you've looked at that and that, right? Then having done that, you go back up to the children and you sort of say, does this match with this now? And I guess I should also say, when you swap the places of this and this, yeah, I mean, we're literally talking about a swap, aren't we? Or is it a swap, or is it a... It's kind of like an insertion sort, isn't it, really? I guess it's like, you know, having compared this against this, you then continue, and what you're sort of saying is, if you found this, then you need to be relegating, or you need to be incrementing this entry and this product index, you know, the product index of everybody in the interim, interceding things, you need to be incrementing their product index by 1, and you need to be decrementing you need to be setting ours. So the person that was 07, we need to be setting that to be back at whatever this is. So how the hell do you communicate that? I mean, surely there's a way to encode that. I mean, clearly I think you would be talking about a specific... Right, you've got 1,7 has to become... Right, so you just match directly against 1,7, and you just straight up say, look, that's going to be 1,6. Then, I could do with a bit more people actually interceding here. I guess we could have tried it out on Hera, couldn't we? Like if you just stick MISC down here, I guess. But I think I can imagine it. It'd be basically like, well, you know that you're talking about 1,7, so that's the upper range. You change it to 1,6, and then you just sort of say that everybody between 1,6 and 1,7 right, which includes this, you just increment their thing. I think that's just all you say, isn't it? It's like min-max, right? The max is the 1.7, which you're going to be changing to be the min, 1.6, and then everyone who was 1.6 up to, but not including the 1.7, you just increment those. So I guess that's all you do, actually. Yeah, that probably is all you do. And then you send it to the book, and then you compare this against this, just to make sure that this is actually still matching. And in our case, we've also removed these guys, by the way, haven't we? So we've removed those, but the count of these should already have been decremented to 2, 0 and 2, 1. So I think they should already be correct at that point, I think. Right. And then you encounter risk, and according to what we said in putting that there, this will have been implicitly written out to there. So you're testing against risk, and you see that they match. Yeah, that's fine. Then you descend into this children. There's no children. You then check out any residual garbage in here to remove. There's nothing, so then you just continue on. So then you see Drake. Does Drake match with bitwise? No. So what you need to do is you then, I guess, we were kind of saying, you go through the rest of the dudes and you see if Drake is anywhere. If it is, then you just swap them in. Otherwise you need to add this guy, and then having added this, you increment the product index for generation 0 to 3, and then you say that everybody who's 3 and up of generation 0, you increment their product index. Right. I think that's it. And then you descend into their children, there's nothing. Again, I think just do the residual things, even though we kind of know that there's going to be none because it wasn't in the database anyway. Then you go on to bitwise. You say, does this match with this? Yeah, it does. Having inserted OBBG here and Drake there, that matches with that. Descend into this. Does this match with anything in there? It doesn't. So insert a dude, and then just say then go and update the assets of everybody in generation 1. Actually, I guess technically you do this and then you just, yeah, actually maybe you do it piecemeal. I was going to say you do that and then do this, and then you can increment the assets by 2, but maybe you don't actually, maybe you just do it piecemeal. So you say, you see this, and then having added this, you just say that everybody who was 1.8 and up, you increment their dudes, which is going to be nobody because there was nobody that was that and up. But you still have to do it, just in case. Descend into their things, there's nobody. Remove the residuals, there's nobody also. Continue on, 1.8. You compare this against any children which is no one to compare it with, so you need to be adding. You then go into the assets and offset the 1.9s, increment the 1.9s, then go into its children, which there are none, and remove any residuals. And then you're away, aren't you? So, unless I'm very much mistaken, which I surely am, that seems completely doable. And I think we're doing it in a way that would be sensible. Right. We're doing it depth first. Keeping a tally of where we're up to in terms of the generation and the number of entries in that generation. We are able to insert offsetting the assets, the asset landmarks. We're also able to swap by passing the min and max indices. Right. We're also correctly removing any residual stuff. So yeah, I think I've worked through how this should work. Let me go and get some food, and then I reckon we're going to come back and we're going to try and implement it. I don't think I've missed anything. But we'll see. Like while meeting, we'll see if I've missed anything, and we'll address it in the next one. So yeah, that's all for now. Thank you very much, Jason Harris, for being here for this one. Done a good an hour and a half. We fixed up the whatever that problem was. It was the setting of the product index in the neighbourhood. We fixed that, and we've also started to plan out this situation here for synchronizing trees. So yep, thank you very much once again for being here, for being fantastic, and especially thanks to Jesse for teaching us about making straight lines in GIMP by clicking the start. Well, it's you actually just need to hover over the start point, hold shift, and then click the end point. And you can also use control to constrain the angle. So yep, that's it. Till next time. Farewell for now.